So how fast do horses run? Kentucky Derby winners top 30 miles per hour, as shown in this graph here. The graph shows the percentage of Derby winners that have run slower than each given speed. And note that a few have won running less than 33 miles per hour, but about 86% of the winning horses have run slower than 37 miles per hour. And this is telling us that this is a cumulative frequency graph. So if you read the chart, these are winning speeds in the percentages. And so they're looking at 37 miles per hour. That gets you at about 86%. Okay? That's the 86% of the horses that win are doing 37 miles per hour. Okay. So now what they're asking us to do is figure out the median speed. The median speed is about 50% of the winning horses that ran slower. So find 50% and then just move to the left. So if we're gonna, because this is a cumulative frequency graph, we're gonna, well, let me do it this way. This might be better. I'm just going to extend out to here. And this is the point of interest right there, this little corner. Okay? And what would you guess that is about?
Maybe 36.2 or 0.1.
Yeah, we'll just say 36. Right, so we're going to look at this point right here, and I'm going to estimate that the median would probably be about 36 miles per hour. Okay, now we got to estimate the quartile ranges. Well, the quartile ranges are 25, right? So to do that, I'm going to go to the 25th and 75th percentile. So I'm just going to take my little box, and I'm going to move this up to, whoops, wrong one. Well, I'm just going to get rid of this. I'm going to go to the 75th percentile, which 70 is right here. This is about 75 roughly. I'm just going to wait for that to kind of jump in there. And so I'm interested in this point. So for B, oops, that's not good. The first quartile is the 25th percentile, and I just located the 75th percentile. What would you guesstimate that would be? It's between 36 and 37, but it's closer to 37, right? So now let's move on and do the 25th percentile. So again, I hope I'm not going too fast, but what I'm doing is here's 30, and then between here and 20 is 25. So I'm just guessing it's probably about here, and I'm just drawing a grid where it intersects the graph. Okay? And so what I'm really interested in is this little corner right here. That's all. And that looks like about 35, right? So those are the quartiles. So now it says estimate the range and the interquartile. Well, the range, you just take the minimum minus the maximum. So I'm going to take the maximum value and subtract the minimum value from it, and that gives me the range. Right? So my highest value is 38, and then my lowest value looks to be about 31. I got to move my box out of the way to see, but we're just going to look for the smallest green dot. Yeah, it's close to 31. So I'm just going to, over here, I'm going to say 38 minus 31. So then my range is 7. Now for my interquartile range, I'm just going to take 37 Q3 minus Q1, and my interquartile range is 2. Okay. Oh, and I should mention the units. This is miles per hour. And this is miles per hour. Oh, I'm running out of room. So now for D, it says create a box plot with these speeds. So over here, actually I'm going to do D over here because I'm starting to run out of space. I'm going to draw a grid. And really what I'm going to focus on is probably my fence would be about 32. And my upper fence would probably be like 37. We'll make it 38. We could make it 31 to 38. It doesn't matter. And then I'm just going to label the median. And we said the median was about 36. So this is the median. We said that the quartile 3 is 37, so it's just going to be a little bit above that. Quartile 1 is going to be 35, so it's going to be about down here. So that's the box. Q1, Q3, and the median. And then my fence would be my lowest value, which is 31, so I'm just going to go a little bit below the 32. And then my maximum value is 38-ish. Yeah. It looks like it curves off. So my upper fence is going to be the maximum value here. So this is the min. This is Q1. Yeah, what's your question?
Why the minimum is 32, not 31?
I'm trying to draw it a little bit below 32. Okay, because this is the minimum value here.
Oh, okay.
And it's hard to draw with this pen, but yes, I agree with you. The minimum should be 31. This is Q3, and this would be the maximum value, which looks to be about 38. Are there any questions on that? Oh, wait, we still got to do E. So this is D. This is part D, the box plot. And then E says write a few sentences about the speeds of the Kentucky Derby winners. So now we got to take this information and then like talk about it somehow. I would say that it's skewed left. The slowest winning speed. So now we just got to put it in regular terms, right? Slowest winning speed is 31. The highest is 38 miles per hour. I know. I'll I got to make it smaller is the problem. There we go. What else can I say? Well, the interquartile range is important.
Yeah, so like you can say that 50% of the value is gonna be 35 and 37.
Yeah, but we gotta use that in words. So for example, like I could say 75% of the winners are 36 miles per hour or higher, right? Because that's what we want to do, is we want to use this data to kind of get some, to do something with it, right? So how does all this relate? So we'll just stop there. You can, the answers will vary there. But let's say Mr. Adams wants to breed racing horses, and I got a racing horse, so I think, man, this is a good horse. I should be able to do something with it. But the horse only runs at 35 miles per hour. Well, they might win, but I got to set a goal to have them run at 37 miles per hour or 38, depending on the data. If I want a chance at winning, I can literally figure out what percentage I'll have at winning based on these speeds. And by the way, all the other horse owners are going to do the same thing. Okay? So then my trainers are just going to take that horse and try to figure out how they can help that horse reach 37, 38 miles per hour. If I can get a horse to reach 38 miles per hour, I've got a pretty good shot of winning, right? So that's what this data does, and this is how you break it down. Are there any questions? Okay. And we do this, the Olympics are on TV right now. Some of those athletes, they do the same thing with their own sports. They look at the data and they say, well, I got to beat this time. I got to lift this much weight. I've got to swim this fast. I've got to, and they just keep working at it until they reach those goals.
Oh, mister, I just noticed something. Why is 2 plus 2 equal to 5?
Why is what?
Why is 2 plus 2 equal to 5? You know that?
Oh, that is a joke, and I didn't write it on there.